All right, let's get right into it. We're going to break down the 5 essential principles you absolutely need to master before you even think about touching a modern vehicle dynamic control system. Honestly, this is the stuff that separates the real pros from the amateurs.
So here's the classic scenario, right? You see that one single warning light pop up on the dash. But what does it mean? Could be a traction control fault, an ABS problem, or hey, maybe just one wheel speed sensor acting up. The point is, without a rock-solid diagnostic process, you're just guessing. You're throwing darts in the dark. And that's the perfect lead-in to our very first principle. You've got to see the whole system. You can't just get tunnel vision and focus on the one part you think is broken. You have to understand how everything is connected and how it all talks to each other. You know, today's cars aren't just a collection of parts anymore. They're these incredibly complex, deeply integrated networks. And sitting right at the heart of it all is the Electronic Braking Control Module, or EBCM. Seriously, think of this thing as the central brain of the operation, juggling inputs from dozens of sensors to manage everything from anti-lock brakes all the way to adaptive cruise control. Okay, now this is where it gets really interesting. Look at this. Your ABS, your traction control, and your stability control. All 3 of them are depending on the exact same accurate data coming from the wheel speed sensors. That is one sensor feeding 3 absolutely critical safety systems. Wild, right? And that's the real kicker. One little fault in that single shared sensor circuit, and bam, your dashboard can light up like a Christmas tree. This is exactly why just pulling a fault code is only the beginning of your investigation. To find the true source of the problem, you have to understand the whole system. All right, let's shift gears to what is, without a doubt, the most important principle of all. I'm talking about the one that makes sure you go home in one piece at the end of the day. Let's talk about safety. Look, we all know to be super careful around high-voltage hybrid systems, but here's something people often forget. Those low-voltage, high-current circuits you find in braking systems, they can be just as nasty. They can deliver enough energy to cause some incredibly severe burns from just one simple accidental contact. And this is exactly why those workplace safety rules, especially the one about removing all your jewelry, are not just polite suggestions. A metal ring or a watch can turn a simple slip into a life-altering injury. Following these procedures isn't about compliance. It's about being a professional, and frankly, it's about survival. Okay, so once you've made sure the area is safe, it's time to put on your detective hat. Our third principle is all about learning how to correctly interpret the digital clues the vehicle is giving you. I want you to burn this into your brain. A fault code is a starting point. It is not the final answer. So you pull a code like P0500 for a wheel speed sensor. That doesn't automatically mean the sensor is bad. It could be frayed wiring, a damaged tone ring, or even just a corroded connector. And this, right here, this is the pros workflow. The trouble code, the DTC, it gives you a search area. From there, you analyze the live data streams from the sensors. Is the signal dropping out? What's it doing? Next, you pull up the wiring diagram to trace the circuit. And it's only after all that you can actually pinpoint the real root cause of the problem. Which, of course, leads us directly into our fourth principle. You have to diagnose, not guess. This is all about having a deliberate testing strategy. This is where you prove your theory. And here's a question every great diagnostician asks themselves. Is it possible that my testing method is actually creating a new fault? Because, let me tell you, if you're not careful, the answer is a definitive yes. Forcing a sharp test probe into the front of a delicate connector is a cardinal sin. You can so easily spread the female terminals, creating a high-resistance connection that wasn't there before you started, and now you've just introduced a new intermittent fault that's going to be a nightmare to find later. A real pro always back probes. Finally, we're on to our last principle, and this one is a biggie. Finding the fault is only half the job. A true professional knows the repair isn't finished until the vehicle is proven to be fixed. This is such a classic trap. You replace a component, let's say a steering angle sensor, but you skip the calibration. And the result? The warning light stays on and the stability control system is still offline. You've closed the repair order, sure, but you haven't actually fixed the car. The job isn't done until the system is reinitialized. So your final process has to look like this. You clear all the codes, you double-check that every single electrical connector is fully seated and clicked in, because a loose one that fails on the road is a comeback waiting to happen.
Then you perform any required calibrations, and finally, you complete a road test to verify the fix under real-world conditions.
And that really leaves us with one final question to think about. Because mastering these 5 principles is what elevates you. It's the difference between being a parts changer who just follows a fault code and becoming a true diagnostician who understands the system, finds the root cause, and solves the actual problem.